Hey you.
Me?
Yes, you. You want to know something cool?
Sure.
Goggles and aprons are the two most important things that are in the lab. Now go on and put on your safety equipment.
You mean these things?
Yes, those things.
What is this for?
An apron is to protect your clothes from getting stained from all dangerous chemicals.
Alright, cool.
What are you doing, Julio? That's on backwards.
Is it really?
Yes, Julio.
Like this?
Yes, perfect. There we go. Now you're supposed to tie it on your back. Just like that. Now, put on these goggles. They're supposed to protect your eyes from all dangerous chemicals.
Alright.
Just like that. See? Now you're all ready to perform a lab in your chemistry class. Julio here is a perfect example of what a student should look like during a lab. Except one thing. His sleeves are not rolled up all the way. There we go. Now they won't catch on fire. On the other hand, Albert here is a terrible example of what a student should look like during a lab. His apron is not worn, his goggles are not worn either, and he is wearing loose clothing. Roll up them sleeves, Albert.
Hey Julio, want some gum?
Oh yeah.
Stop! Never reach over an open flame during a lab.
Oh yeah, that's right. Thanks, man.
No problem.
Hold it right there. What do you think you're doing, Julio?
I'm trying to chew some gum.
Another rule during a lab is to never eat, drink, or chew gum during a lab.
Oh, sorry.
This, my fellow classmates, is a scale. It is used to weigh objects in grams. The way you use it is first it needs to be plugged into the wall and to the scale. Then you press the on button. After that, you put the object on the scale. And ta-da, record your data.
Why, hello there. This is a beaker. First things first, make sure it's not cracked. Primarily, it's used to hold liquids. Although it's inaccurate, it can still hold liquids and measure them.
This, my fellow classmates, is a pair of tongs. Its purpose is to carry hot lab equipment. An example, I'm carrying this flask. If it were hot, it would protect me from getting burned.
Hello class, this is a Bunsen burner. In order to turn on the Bunsen burner, you need to remove the cover from the table. Once you do that, you need to plug in the pipe into the gas pipe. Once you do that, you can turn on the gas pipe. And then in order to ignite the flame, you need a lighter. I almost forgot. Let's see. The purpose of this Bunsen burner is to heat up objects. Well, hipper my jibbers, I almost forgot. This little thing right here. You know what this is used for? It's used to control the flame.
This is a graduated cylinder. It's used to measure liquids more precisely. In order to correctly measure the liquids, you must use the bottom of the meniscus. A meniscus looks like this, a concave line.
Accuracy. Accuracy is the description of how close the measurement is to the true value of the quantity being measured.
Precision, the exactness of a measurement.
This point on the target is accurate because it is in the center, which is what we want. However, these points are precise because they are consistent. I don't know. These points on the target are both accurate and precise because they are located in the middle and they are consistent.
Significant figures, also known as sig figs, tell us how precise the measurement is. The more significant digits there are, the more precise the measurement is. When determining significant figures, ask yourself, does the number have a decimal point? If yes, read the numbers left to right. If no, read the numbers right to left.
When adding and subtracting sig figs, we look at the least number of decimal places. An example here, 12.376 grams plus 3.0147 grams. So the least number of decimal places is in the thousandths place. So now we just add it. 7, 0, 1, 8 plus 1, 9, 3, 5, 1. So this is our answer.
When multiplying and dividing numbers, we look at the least number of sig figs. For example, 2.51 grams multiplied by 51 grams equals 130 grams because we round. When doing a lab in class, you will encounter many errors. You can calculate them by using percent error. Percent error is absolute value of expected value minus real value divided by accepted value, multiplied by 100.
Hey Gabby, what about sig figs during percent error?
Well, let me tell you, Leo. You should also take into consideration sig figs when calculating percent error.
Hey Gabby, what about sig figs during percent error?
That was perfect.
Hey Gabby, should you also take into consideration? Hey Gabby, what about sig figs during percent error?
Let me tell you, Julio. You should also take into consideration.
Hey Gabby, what about sig figs during percent error?
You should take. I don't know what this is after
You
that.
should all eat.
Come on.
I'm so sorry.
You're messing.
Oh,
How many
okay.
times have you
This is
stopped,
serious,
Gabby?
Julio.
How many times?
Damn, bros, though.
No, wait. No, wait.